Okay. So quick reminder, because I already forgot in my last lecture, but I'll watch the lecture channel on Discord. If you have questions, hit me up in there, or the old-fashioned raise your hand works fine as well. Forgot one thing somewhere in here. Hey, there we go. And a quick logistical note. I don't know if anybody cares about this, but I say it each time anyway. When I start a lecture, you'll often see me downloading the slides. I'm going to go through this routine. Pretty much every lecture, you're going to see me do this. So if you're ever wondering, I like to download the slides right before lecture starts for a few reasons. One, I like to make sure that the slides are synced up on the website as to what I'm presenting. So I download it. More of a kind of as a show of good faith that I'm presenting from the exact same slides that you have access to. I just downloaded them from the course website. So I want to show, hey, I'm not presenting from something else, because that always bugged me as a student when the professor's teaching from something. I download the slides that they posted. I'm like, all right, they posted the slides, and the slides are completely out of sync. So I download them right before lecture just to make sure. And to keep myself honest, sometimes I make sometimes I make mistakes, and I update the slides right before lecture. I forget to update the website, and then I download the slides and say, hey, these are my old slides. And then I can update them quick and make sure we're all in sync. So if you see me downloading the slides, I don't know if you all care, but I wanted to explain it anyway. All right. I mentioned my phone, so let's jump into it. These first few weeks, I'll give a quick disclaimer right now. I'll probably say this a few times too. These first few weeks go at a very fast pace. We're going to cover a lot of ground. This is mostly 115 material, but in Java. We're learning a new language, so we have a lot to cover with the new language, but most of it is syntax. There's some, I'll always highlight the Java-specific concepts that we're going to cover. We're going to see our first one today, strong typing. So I'll make sure I definitely highlight that more so than the other topics, but a lot of it will be 115 reviews, so the pace goes fast. And then week 3, unit testing, is going to be our first official 116 concept, the first one that's covered in learning objectives. That's when the content 116 content really kicks in, and that's when the pace of lecture, pace of my speech even, will start slowing down a little bit. Because we'll have less content to cover, but the content will be more difficult and brand new to most of you at least. What's up? When do labs start? Next week. Yeah, no labs this week, but next week. That would be, so next Monday, so in 3 days you'll have lab. Yep, and lab next week is about IntelliJ setup. The TAs are going to help you get IntelliJ set up on your machine. I haven't even mentioned IntelliJ yet, have I? IntelliJ is the software we're going to use. It's an IDE, an integrated development environment. That's where we're going to write our Java code, or at least the strongly recommended way to write Java code. If you already have written Java code before and you have something else like VS Code that works for you, go for it. But IntelliJ is the one that's going to be supported by the class. And that's what we're going to do in lab. It'll be more office hour style, and the TAs will help you get set up with that. Set up on your machine and make sure your device is ready for the entire semester. If you don't go to that lab, you won't really offend me too much, but you better have your IntelliJ set up properly if you're going to skip that lab. If I get IntelliJ questions after that week of lab, I get pretty mad. Unless they're really specific issues. Some people run into really complex issues. But you better not be installing IntelliJ for the first time in week 3 office hours going, Professor, how do I do this? Because I'm going to know you skipped lab and I'm going to get mad. So if you're skipping that lab, just know that you're waiving support on setting up IntelliJ. Okay, with that, let's get into it because we got a lot of stuff to talk about, starting with where else but Hello World. Let's do it. This is Hello World in Java. Even that's kind of bright. I don't have that much brightness on the slide. That really brightened up the room. I might go one notch up on the lights. We'll see how this dark mode works for a few more lectures, but I might end up going a little brighter on the lights. But this is the simplest Java example possible, pretty much. Simplest one possible, and it's still pretty complex. So let's break this thing down and talk about all the pieces that go into this. Of course, what this program does is prints hello Java to the screen. That's it. It doesn't do anything else. It just prints hello Java to the screen and then shuts down. So let's talk about all this extra crap around that printing hello Java and talk about what it means. So first, a package declaration. This is the package where this code is going to live. And you can think of this synonymously as the directory where this code is going to be. The file that contains this code will be in a directory called week1. So you can look at the package and know what directory to find that code in. Or if you're looking for a specific package, you can find that directory and you know that's going to be the package. Java will enforce this. If you put if I put this file in a package called week1 and I change the package in the code to week2, well, everything's going to break, Java's going to get mad, and it's going to refuse to run my code. So this does have to be a one-to-one correlation between package name and package declaration and the directory where this code lives. And this is all in relative to the source directory. So when you clone the, like the examples repo, this is, of course, from the examples repo, as I mentioned Wednesday, all the code in the slides should be found in the examples repo. There's a source directory, SRC for short, that's the directory name. And in that directory name, you'll see the whole package structure, and the code is going to be in packages based on which week they're going to be presented. So this content from week 1, you go to source week 1, you're going to find all the week 1 coding examples. That's a little bit chopped up because we started on a Wednesday, so some of it will be a little bit out of sync, but you'll be able to find all the code based on that. Next is the class name. So everything in Java, all your code has to be contained in a class. That's a little bit of an overstatement that we'll talk about later in the semester. We have abstract classes and interfaces, but everything needs to be contained in this top-level object. For now, is a class. Oh, object's a bad word to use there. Of a class. So we have a class, and we're going to call it Hello World, and then all of our code is going to go inside of that class, which is defined by these braces. We have an open brace and a closing brace. That defines the contents of the class, and everything needs to be in the class, aside from package declarations and import statements that we'll see Monday. I don't think we see any of those today. So we're creating a class. We're calling it Hello World. These should all be upper camel case, so classes should have start with capital letters, and then each new word should be a capital letter. And this is correlated to the file name. If I create a class called Hello World like this better be in a file named helloworld.java. So if we put that all together, we have this class, Hello World, in a package week1. To find this code in the repo, we know that's going to be in the source directory, the week1 subdirectory, in a file called helloworld.java. And just like the package names, Java will enforce and yell at you about the class names as well. If you have a class name that's mismatched with its file name, Java's not going to like that so much. I think Java will still run your code in that case, but it won't like it. It'll complain. Maybe it doesn't run your code. I don't know. I just name them properly, and I don't have to think about it. And then we get this big monstrosity, public static void main string brackets. This is what's called a main method, and this is where our code starts. So in Python, you have a .py file, and you run that file, and it just runs all the code in the file. It starts at the top and then runs all the code down to the bottom. Java is not quite like that. Java is going to start your code at what's called the main method, and like most programming languages do this. And in Python, we usually set it up in a way to kind of pretend that Python does this in most applications. But Java explicitly needs a main method, and this is where your program starts. If you don't have a main method, you don't have a program. You can't run it. You need a main method because that's what tells Java, this is where my code is. Run this code when we run this file. So if you run this file in the examples repo, which we haven't really installed IntelliJ, we haven't quite got there, but after lab, you'll be able to run it by right-clicking this file, clicking run, and what it's going to do is execute the main method. So this is a special method, and now is as good a time as I need to say this. You're going to hear me say method all the time throughout this entire semester. When I say method, you hear function, I'm completely okay with that. They're basically synonymous, but in Java, they are all technically methods, not function. Java doesn't actually have functions. It has some things that it pretends are functions, but they're still methods. And the difference between the two is a method is a function, what would be a function, but that lives inside of a class. Since all of our code lives in a class in Java, we don't have functions, we only have methods. So when I say method, you'd think, oh yeah, those are like the Python functions I learned about. I'm perfectly okay with that if you just hear function. But I'll say the correct term just to be consistent and technically correct on it. I'll say method the whole time. So the main method is defined like this. Let's break this thing down. We have public, static. Oh, I'm not talking about public yet. I'll talk about public in a minute. But static void main, we're going to know what public, static, void, class, for what it's worth. We're going to learn all of these throughout the semester in about 4 weeks, I think. We're going to know all of those keywords, what they all mean in great detail. For now, I want to keep it at a very shallow level, so just a very high level. Static means that we can call this method without doing extra work. Later on, we're going to see that extra work is creating an object of this type, using the class as a template to create objects. We don't have to think about that quite yet. We'll get there. So static means we don't have to do extra stuff to call this method. We can just call it. Void means this method doesn't return anything. When we're running a program, it doesn't make sense for it to return any value. We just want to run this method. That's the entire program. Main is the name of the method, which must be exactly main, M-A-I-N, all lowercase. If there's any misspelling, any miscapitalization there, it's not a main method, and Java will not run your program. It has to be exactly that. And then string array is how we read this. The parameter is of type string array. A lot of that part won't make sense either quite yet. But this takes a parameter of type array of strings, and we need that parameter to be able to make this a main method. So we need it to be public, static, void. It has to be named main exactly. It has to take exactly one parameter, and that parameter has to be of type array of strings. If we have all of those pieces, all of those together, we have ourselves a main method in Java, and Java is going to know where to run our program. If any of that's missing, we don't have a Java program. We have some Java code, but we don't have a Java program. So all those have to be there. Exactly like that. So if you're writing a main method, we need every single ingredient of that. And public, I said I mentioned public. Public means we can run this code from anywhere, which for a main method, that's pretty important. We want to be able to run this code from anywhere, from outside of this class. If we use something other than public, we can still run the code, but maybe only from inside the class. But if it's a main method, it's got to be public, so other people can call this code. That's allowing other people to access the code, which other people is us from our IDE, which is outside of this class, outside of the Hello World class. So all these ingredients together, mix all this together, and you got yourself a main method. And if you think that's confusing, which you really should think that's confusing, this is why we don't do Java in 1.15. I'm surprised they still use Java in AP, in high school AP courses. Day one of Java is all of this, which it's a lot. We don't need to know what all of these things are. And I didn't go into detail on any of them. That's just surface level detail. It's a lot. Python, it was print hello Python, and that's it. And then you click go and it worked. So that's why Python's a good 1.15 language, but you're all ready for this now. 1.16, we're doing Java. All right, or you don't want to remember all that. I'll try not to sound too old, but back in my day, we had to remember all this stuff. Now, if you're using IntelliJ, you type main, and autocomplete will say, oh, it looks like you want a main method. You hit enter, and it just does all this for you with the right formatting, all the right keywords, the right spelling, the right capitalization. Everything will be there. So you don't have to think about it too much these days. And then, after all that, we can finally write some Java code that does stuff. And what we're going to do is print something to the screen, just print a string to the screen. And for that we need, because it's Java, it has to be needlessly complex, system.out.println, and then your string. We can't just do println, we have to do system.out.println. In IntelliJ, we have a shortcut for this, sout, and then hit enter, and it'll do all of that for you. So if you do main, S out, you'll get all this code, aside from the class and the package. Okay, that's Hello World. Frickin' 15 minutes into your first lecture. So much in Java. And for what it's worth, Java statements all end in a semicolon. You need your semicolons. That's how Java knows that your statement ended. If you don't have your semicolon, things break. This used to be a bigger deal. It's not that big of a deal now because IntelliJ will underline in red and give you very clear error messages that say, you forgot a semicolon. Expected semicolon, but there's no semicolon. And right here is exactly where I'm talking about. And then you go, oh crap, I missed my semicolon, and you type it in. It used to be a lot more difficult to find your missing semicolons and frustrating. Pretty easy these days, so I don't have much to say about it. Just don't forget your semicolons, and if you do, listen to the IntelliJ error messages, and it'll fix it for you. Okay, any questions so far? Back up to this slide. Any questions on Hello World? Get on with it. Variables and methods. Here we're going to start talking about our first Java-specific thing. I guess technically packages, access modifiers. I guess we talked about a lot of Java-specific things, but I didn't go into much detail. A lot of those are topics for another lecture. But this one, we're going into details already. Variables and methods. Two of the first things that you see in 115. Yeah, I'm going to have to. I won't do it today, but I think I have to go up on the lights. Even these mostly dark slides are pretty bright. Variables and methods. So let's talk about it. Of course, you did variables and functions. It's Java, so it's methods. Same concept. Same exact concept from 115. So let's talk about this. So this program is going to declare a few methods, declare a few variables, call the methods, basic stuff. But in Java, so it's brand new, let's talk about it. So Java is strongly typed. This is our first Java-specific topic that we're going to go into with more detail. And I say Java-specific. I just mean that as opposed to Python. A lot of languages are strongly typed. Java is just, if you're going no programming experience to 115 to 116, this is your first strongly typed language that you're seeing. So what strongly typed means is when you declare a variable, that variable must have a type. I'm declaring a variable called num here, and before I declare that variable, instead of doing, oh, you didn't do JavaScript last semester. Instead of doing nothing, you do nothing in Python. You just declare your variable and start using it. So instead of just declaring your variable by typing the name and then equals and then start using your variable, in Java we have to declare its type when we declare a variable. So when I declare a type, double num, I'm declaring a variable named num that has type double. And we can only declare a variable one time. When we first use a variable, we declare it by specifying its type. What this means is that this variable num can only ever store values of type double. In Python, you didn't have this restriction. I could say num equals 2.4, and then on the next line, num equals hello world, and that would work perfectly fine. Python would be like, fine. In Java, we declare num to be of type double. It can only store a double. If I said on this next line, num equals hello world, I'm going to get an error, and Java's going to actually refuse to even run my code. It won't even touch my code. So this variable can only ever store a double. And that's going to be true for every single variable in Java. Every single variable needs to have a type, and that type cannot change. That variable, this variable num, can only ever store doubles forever. Can't store anything else. So this is the first big change, the big shift going from Python to Java. And I'll argue it's a little bit of extra work up front, but I'll argue that strong typing is much, much to our benefit as programmers. It significantly reduces the number of errors we get when we run our code. In Python, you'll see a lot of errors. When you run your code, it's going to say expected string, but you gave me an int, and your program runs and crashes, and there are no errors before your program completely crashes. With strong typing, IntelliJ is going to tell you right away. You type something using the wrong type, it's going to say, hey, that's a int, we need a string here, you messed up, maybe fix that, and then you get to fix it right away before your program crashes, before you release it with bugs. So I argue that this is a very, very, very good thing to have strong typing in your language. All right. So now let's declare a method and call that method. Multiply by 2, it's going to do a very simple thing. It's going to take a number as a double. A double, very briefly, is a number that can have a floating point value, so 2.4. I can't have that 0.4 if it's not a double. But if you think of doubles as just numbers for now, that's fine. So it takes a number, multiplies it by 2, and then returns that multiplication by 2. Very simple method. You would never actually write a method like this. You would just multiply by 2 inline. But for our first method, we're going to do this one. All right, so let's talk about this. Method declaration. And one thing to note, because I always get this question, you can declare your methods before you use them or after. It doesn't matter which order you do things in. Java's going to look at each method declaration and process all of the method declarations and then go to your main method and start running your code. So I didn't do it here, but if I put the main method first, this program would work exactly the same. But typically we put the main method on the bottom just by convention. The main method will be the last method in a class. So I'll always put the main methods at the bottom of my classes. But they don't have to be there. It would still compile, run, everything would be fine. All right, so first, public static. We saw these two keywords before. Public means we can call this code from anywhere. For what it's worth, this one doesn't have to be public. We're only calling it from this main method. But we're just going to have everything be public for a while until we start talking about other access modifiers. Static means we can call this method without some extra work. We don't have to create an object of type variables, functions. We can just call this method without that extra work of creating classes or creating objects, which we haven't talked about yet. So good thing static's here. We don't have to talk about objects quite yet. And we're going to do that for all our methods. I'm going to stop talking about public static because all of them are going to be public static until week 4. Yeah, week 4, when we talk about classes and objects. So we're going to forget about public static for a while and just get used to it being extra words that are in all of our methods, all our methods start with. And then double. This one we do have to care about right now. We're talking about this one right now, the return type of this method, the return type. So every single variable needs a type. We talked about that. Also, every single method needs a return type. So we have 2 different places where types are going to be required. Every single method you write needs a return type. So when we say this return type of this method is double, like we do here, we're saying this method will return a value of type double. 100% guaranteed all of the time, it will return a double. And this is a contract that we sign with our blood and sweat. It goes into this. Java takes that 100% as fact, and we must return a double. So this method has to return a double. If we don't return a double, Java's going to say you broke your contract and refuse to run our code. So we have to return a double if we say this returns a double. So we're going to say this method returns a double, and it will return a double, and we have to make sure it returns a double. This method takes one parameter. Parameters work the same as they did in Python. The only difference is they have to be strongly typed. Parameters are variables. Variables have to have types in Java, so our parameters have to have types. So this method returns a value of type double, and it takes as a parameter a value of type double. So this takes a double. We're going to call the input because I'm not creative enough to come up with something else. And it has to be of type double. So if we ever call this method, we have to call it with a value of type double. If we don't, it's not going to work. So our types have to match. Our variables have to have types, and those types always have to match as we're going through our code. Our methods have to have return types, and that return type has to match wherever it's being returned to. All these types have to be consistent, and Java will hold us to that, which, again, is a good thing. Java's going to basically looking over our code, like looking over our shoulder and saying, hey, those types aren't quite right, and then you can fix that as soon as you type the error instead of after you ship your software to your customers. It's much, much better this way. All right. And then the actual code of the method. methods are defined by these braces. So the body of the method is defined by the braces. Statement endings are defined by semicolons. What that means for us is that white space doesn't matter. In Python, everything was defined by indentation. That's how you knew when your code blocks began and ended. In Java, your code blocks begin and end based on these braces. This is the beginning of the block, this is the end of the block, and if you mess up your indentation and have really gross-looking code, Java's still going to run it. It's going to be fine. White space indentation does not matter in Java. All right, so the actual code of our method is going to declare another variable of type double named x, set it equal to the input times 2, and then return x. We need our return statement on, well, Python did that too, so I don't really have to talk about it. But we need our return statement on every method. Whenever we hit a return statement, the method ends and returns that value. That value must match the return type. X is of type double. We're returning x. Needs to be double. It is a double. Go us. We did it. We matched our types. We're doing great. And when we call our method, we're going to call it, just like in Python, or I keep saying in Python, but any language you're coming from, if you transfer it in or whatever, any language, method calls are going to be the same unless you've started with some very obscure language, but in that case, you should probably just be in the next course at least. So multiply by 2, we're going to call the method by name. We're going to give it a double. It takes a double, so we must give it a double. We're giving it num, which is type double, which everything's a double in this example, so we can't really mess it up. So multiply by 2, give it 2.4. That's going to run this code and return 4.8. And we're going to reassign num. When we reassign a value, we do not specify its type again. We only specify the type when we're declaring a variable. Declare means we're creating a variable for the first time. After that, we don't specify the type ever again. We already told Java it's double. Java knows it's double. We don't have to tell Java again. So num is already of type double, and we're going to reassign it to this new value 4.8. And then on the next line, print string concatenation works. I was going to say works how you expect from Python, but it actually works better than in Python, because Python, you always had to do str and then manually convert your numbers to strings in Python. Java's going to do that for us. This concatenation, since we're concatenating a string with some other value, it's going to automatically convert this to a string for us. So all that talk and waving my arms and saying your types have to match and everything, here's a good case where they do match under the hood, but it gives us the illusion that they don't have to match. We didn't have to convert that to a string because Java's got our back on that one. That's part of the string concatenation operator that can take a double, and then it will convert it to a string for us. So it's doing a little bit of work for us. Then we have another method we're calling. This method doesn't really do anything. It knows it doesn't have or I shouldn't say it doesn't do anything. But it's kind of pointless. That's why it's called why, because why would this method ever exist? And it doesn't have a return statement. It doesn't return anything, and it has this return type of void, which we did see in our Hello World example, but I kind of glossed over it real quick. Let's talk about it right now. Now that we know about return types of methods, void is the lack of a return type. When you say my return type is void, you're saying this method ain't going to return nothing. It's not returning anything. So it has a return type void, meaning we're not returning anything. I'm not going to give you anything back. You call this method, it's giving you nothing back. So void is the way that we're going to do that. And we say that we call these methods for their side effects. This method has the side effect of printing to the screen, but it's not a method that we call for its return value. It's not doing any math or computation for us and getting back to us with a new value. It's just being called for its side effect of printing to the screen. And then whenever we reach the end of the code block for the main method, program's over. Program shuts down, it's removed from memory, everything's gone. So we made it through our first more complex than Hello World example. Strong typing is the big new thing here. Strong typing on all our variables, strong typing on the return type of all of our method declarations. Are global consistent throughout the entire code or by class? So there's no I think I know what you're saying. There's no actual global variables in Java. There's no true global variable, so they would be global to the class. They would be localized to the class at the highest level. You can't have a variable declared at a level higher than the class. So I could put variables up here, and they would belong to the class, but I can't put a variable up here that would be at a level higher than the class. So no true global variables in Java. So in your memory diagrams, that global space, we shouldn't ever put anything in there. If you do, I'm not going to get mad. Maybe I will. I don't know. I'm not grading the quizzes, so. But any variables declared in the main method, it's kind of the closest we think of as globals. And last semester, a lot of students put those variables in the globals section on the memory diagram. But they really shouldn't be there. There should be a stack frame for the main method, and those variables should go in that main method stack frame. Why don't we strongly type the variables after they have been assigned? Why only when they are created? Because we only have to tell Java once. Once num has the type double, we can't change. There's no mechanism in Java to change the type of a variable. Since it can't change, Java says, okay, I got it. This is a double, and that's never going to change because I'm not going to let you change it. So there's no reason to tell Java again that it's a double. It's just something we don't have to do, so Java doesn't make us do it. Multiple classes equals solar system. We could do that. Or create a planet class and create multiple objects. All right, any other questions on this one? Yeah. Kind of. Let me give a longer answer to that one. So if the data type if we call multiply by 2 with a different data type, will we get an error is the question. Sometimes. So if I give this a string, for example, that's going to give me an error. I give it a Boolean, it's going to give me an error. A lot of types, it's going to give me an error. But there's one exception to this. If I give this an int, and you'll notice right here, if you already know things that I haven't told you yet, I guess you wouldn't know this yet. 2 here is actually an int value, and input is a double. I'm mixing types here, but whenever you give an int where a double is expected, Java will auto-convert that one for us. It'll say, you got an int, I can represent that as a double, so I'm just going to do that for you. So an int wouldn't get us in trouble here, but most other types will. Yep. Ooh, that one, I got the next kind of. So the only type I've talked about so far is double, so I want to start introducing new types. Let me take a few more questions. I will get back to you through the next content. Yeah, what's up? If you run that class, so a class can only have one main method, and when you run a class, it'll run its main method. So you don't have to explicitly say run the main method. You would say run the class itself. So in IntelliJ, you'll run the actual class. You'll see when you open it, there will be green arrows next to the class name and next to the main method name, or you can right-click the file and go to run. But all three will do the same thing. It'll run the main method. Yeah. Yes. Yeah, so you can reuse variable names if they're in different methods. Yes, because they'll be in different stack frames too. They'll be completely isolated. Yeah. Are you talking about objects? Right. So you can call a class's constructor from the main method if that's what you're asking. But that's not till week 4, but we will see that. But yes, it can. And the main method, from the main method, we can call non-static methods as long as we create objects first. But we can create objects of that same class that we're in. That's your question, right? Okay. Yep. Yeah, we can. All right. Let's talk about a few different types. If you have a variable and you have a class double, so let's say double num equals 2. Would that work even though 2 is an int? Yep, that one would work. You might have typed that before I said my explanation. So if I just said 2 here instead of 2.4, that's still going to work even though 2 is an int. You'll be able to assign it to a double. That's one of the exceptions of Java. Java does try to help us out when it can. But if we give it broken code, it's not going to be able to work with it. But if we say, here's an int, assign it to a double, it's actually cool with that. It's fine with that. The other way around, not so much. But let's talk about what int and double are, since we're talking about them a lot. Let's talk about these things. So let's talk about these 4 types. With these 4 types, we're going to be able to do most of what we're going to do throughout the semester. So let's talk about these 4 types to get us started. So double, we've talked about this. We used it in that example, but let me get a little more in depth. This is a number that can have a floating portion, so I can have a decimal portion. It doesn't have to be a whole number. It can be any, I don't want to say any number, but it can be, it can have a floating point value. It can have a decimal portion, not just a whole number portion. So if you want a number with a decimal portion, you're going to want to use a double. There are other types. For those of you who know of the other types, yes, there are a lot of other types. We're going to stick with, if I need a decimal, I'm going to use a double. If we don't need a decimal, I'm going to use an int. I'm not going to use floats, longs, shorts, bytes. I'm not going to use any of those types in this class, just to keep it as simple as we can. We just need one of each type of type. We don't need to introduce floats and doubles. But doubles can't represent numbers exactly. There are a lot of numbers that we cannot represent in a double. And most of the time, we don't have to care about that. You never cared about that in 115, I'm sure. But I guess I'm not positive, but you probably didn't have to, or else they're doing something weird in 115. But in 116, starting on week 3, we are actually going to have to care about that. So I'm just going to foreshadow that for now. But doubles, floating point value. String, you're used to these. For what it's worth, string, the type, starts with a capital S. There are many, many reasons for that we'll get into, at least briefly, throughout the semester. We're actually going to pretend that it's a lowercase s, but in your code, it's going to be a capital S. Not much to say about them. It's the same as in Python. It's a sequence of characters. Int is going to be our whole number value. Int for integer. These have to be integer values. They can be positive or negative, but they have to be whole numbers, no decimal portion. So an int can always work as a double. The decimal portion is just 0.0. But you can't go the other way around. Java will automatically convert your ints to doubles if you put an int where a double should be, but not the other way around, because what's it going to do with that decimal portion? If I say num1 equals 2.4, int num2 equals num1, I can't store 2.4 in that integer value. It would have to do something with that 0.4. And what it's going to do is give an error and say, I can't do this, I'm not allowed. Even if it is 2.0, it's not going to let you do that. Java won't let you. You have to explicitly say, I want to get rid of the decimal portion. You have to be explicit about that and say, no, I want to do this. And then it'll do that. But it's not something we'll do this semester, or at least not required on any homeworks. So int has to be a whole number. And one thing we need to watch out for with ints is something called integer division. We can divide ints. We can multiply them, add them, subtract, of course. But we can divide them, which brings up this strange issue. When we divide 2 ints, and neither one of these numbers have decimals, if I put 6.0 divided by 4.0, then I would get 1.5 as a double, because those would be dividing 2 doubles. But if we're dividing 2 ints, I didn't put decimal places here. We're dividing 2 ints. The result has to be an int. So the question is, what do we do with that remainder? We have a remainder of 2 here after the division, or we have a decimal of 0.5, and the answer is it's just truncated. It's just deleted, gone. We only take the whole number portion of the division, the quotient. We don't take any of the remainder. It's just deleted completely. Even if we have something like 99 divided by 100, we have 0 with a remainder of 99 or 0.99, the decimal portion is just deleted, and we get 0 as the result. So it's always effectively the floor of the result is taken. So this is integer division. 2 integers divided by each other is always going to result in an integer. So something to always keep in the back of your mind when you're programming. If you're dealing with integers and you want that decimal portion, convert at least one of the integers to a double before doing your division, or declare one of your variables as a double before you do your division. And Booleans, they're true or false. I got nothing else to say about them. For what it's worth, lowercase t, lowercase f, as in Python, it was capital T and capital F. I had nothing else to say about them. They're Booleans. You got Booleans. All right, and let's do a memory diagram. I'm going to start, I keep telling myself this semester I'm going to start using the tracing tool in lectures, but I have a lot of slides with memory diagrams, and at least for this one, and probably the first bunch, I'm going to do them in slides. But I'll try to start using the tracing tool that you'll use in labs that you used in 115. And this one will mostly be review for 115, but those of you who didn't take 115 here, this is your first exposure to memory diagrams. We start talking about them. I'll go fairly quickly since most of you have had extensive practice with these things, at least for what we're going to do with them today and next week too. And week 3. Not till week 4 we're going to do new stuff with memory diagrams, which is great. It's the first semester I can say that. You were the first 115 to go through memory diagrams. I'm glad I can rely on that knowledge. All right, so let's start this code. As we're doing a memory diagram, mostly for those of you who haven't seen memory diagrams before, quick background. Memory diagram is going to track what's happening in memory when our program runs. So every time a variable is declared or a method is called, we have something happening in memory. And when I say memory, I mean the RAM sticks in your machine, your random access memory. Our program is allocated a certain amount of memory, and we're able to store everything to do with the program execution in that memory space. We have 2 different types of memory. We have stack, which is most of what you use in 115. You pretty much hang out in the stack almost all the time except for your couple of data structures. And the heap. The stack is where all of our method calls and all of our variables are going to go. And then the heap's going to be more dynamic memory, which is going to be great. We'll start talking about it next week very briefly in the same regards that you did in 115. And starting week 4, we're going to be all over the heap. We're going to do all kinds of stuff over there. For now, we just need the stack. And then one section for input-output, which is really just output. We never do input with it. But the output, this is every time something's printed to the screen, we're going to put it over in our little I/O input-output section, or in-out. So the very first thing we do, we print to the screen. So we go to our in-out section, and we put whatever was printed to the screen in that section. Then when we declare variables, we have our stack split into name and value. Name of the variable, and then the value that variable is storing goes in the value column, which I think even when you're first seeing memory diagrams, I think that one's pretty self-explanatory. I don't think that's mind-blowing or anything. But we're going to put the name and value so we can track every variable that's currently in memory. When we declare a variable, that variable is allocated a space on the stack in stack memory, and its value is sitting there next to its name. So we have this lookup table, and this is what the program uses to find out whenever we say num. I don't even use the variable num. But whenever we use a variable, it's going to look up in the stack and say, okay, what's the value of this variable? And find its value in that table. Test 3 incident. What was the test 3 incident? We had test 4 incidents in the past. Remember much test 3 incident. Test 4 used to be way too hard, by the way. It's not an issue anymore. Not as much anyway. It's still hard because it's hard material, but it was way too hard before. So each variable we declare, we're going to put its name and value on the stack. And for those of you that this bugs me too, strings do actually go on the heap, but we are going to put them on the stack. It bugs me, but it's for the best. In 116, we're going to put strings on the stack and pretend that they don't go on the heap. For those of you who know, yeah, it might bug you. It bugs me too, for what it's worth. But that's where we're going to put them, is on the stack, and make them pretend that they behave like primitives. If those words don't make sense to you yet, don't worry, we'll get there. But we are, for what it's worth, going to put strings on the stack. We're going to treat them as values, not as references. Again, if those words don't make sense to you, don't worry about it yet. But strings are going on the stack. Don't forget your integer division. 6 divided by 4. Num3 is going to get the value 1. And then Boolean. We're going to create a Boolean value. Has the value true. We're going to print to the screen. And this is where we look up a value. What's the value of num3? Your program doesn't look at the code. It's not going to look back at the code and recompute num3. What it's going to do is look in stack memory for a variable named num3 and look at its value, which is 1. So that's what gets printed to the screen. Then we have our first stack frame. A stack frame is created every time a method is called. When a method is called, we get an completely isolated environment for the method call. We denote that with a solid box in our memory diagrams. And any variables that are declared within that stack frame, within that method call, are inside this stack frame, this isolated portion of the stack. And from inside a stack frame, you cannot interact with any variables outside of the stack frame. Completely isolated environment for many reasons, one of which is we can reuse variable names inside a method call. We can use variables that were used outside the method call without worrying about reusing the same variables and having some variable name collisions, among other reasons. So with the stack frame, we have our solid, bless you, we have our solid box. We're going to write the name of the method being called, bless you, and we're going to draw a return arrow to the variable where we're returning the value to. The return value is being stored in num2, so we're going to draw a return arrow to num2. Then the first variable that goes inside the stack frame is the parameter in this case, or any number of parameters. Then any values that are declared inside the stack frame, while in the stack frame, when we return a value, we're reassigning num2, we cross out the old value and write the new value next to it. And when a stack frame returns, we're going to cross out the stack frame. When a method call ends, its stack frame is removed from memory. We denote that by crossing out. All these clocks say different things. By crossing it out. Print to the screen again, call another method. That method returns. We cross out that stack frame. It's a very quick first memory diagram. But since there's nothing new there that you haven't seen in 1.15, I think we should be good with a quick one. It's too quiet. Why? Just work. Okay. Well, there should be